On November 5, 2025, the Virtual Telescope Project unveiled two new images of the interstellar object 3I Atlas, which left the scientific community grappling with even more questions than before. The photos revealed Atlas as an intensely compact light source, devoid of any visible comet-like tail. This striking absence only added to the growing mystery surrounding the object. Even more perplexing, the appearance of Atlas has remained almost identical to the images captured by the Hubble Space Telescope back in July 2025. According to Harvard astrophysicist Avi Lowe's calculations, an object like this should have lost at least 13% of its total mass, over 5.5 billion tons of material. Yet, the fact that there's no massive glowing coma, something we'd expect with such a dramatic loss of mass, remains a true enigma. To help put this in context, let's compare Atlas to another comet that was also photographed during this time. Comet Lemon, a well-known object in our solar system. Lemon's images follow all the standard expectations, showing a clear and distinct tail that extends outward, formed by solar radiation pressure pushing gases and dust away from the comet. In contrast, Atlas has no such tail, no visible signs of the expected material loss, and no cometary glow. It remains disturbingly clean, raising questions about how it could possibly exhibit non-gravitational acceleration without the corresponding visible trail. As Avi Lowe suggests, this anomaly is just one more piece of evidence pointing to the fact that Atlas isn't behaving like anything we've encountered before. This brings us to a critical and pressing question that the scientific community must face. Could there be something truly extraordinary behind Atlas's behavior that goes beyond our current understanding of physics? Much of the public's concern about Atlas's unusual acceleration has been fueled by misinformation and sensationalism. In this video, we're going to dive deep into the raw data and examine whether this anomaly truly signals something remarkable observing our solar system. On October 29th, as Atlas neared its closest point to the Sun, it began accelerating in ways that gravitational forces alone cannot account for. NASA's Jet Propulsion Laboratory released a report indicating that Atlas had deviated by 4 arcseconds from the trajectory predicted by gravitational models. While this may sound small, it represents a significant discrepancy, especially when you consider that Atlas was 203 million kilometers away from the Sun at the time. To illustrate the magnitude of this deviation, consider this. Atlas is accelerating at roughly 0.02 millimeters per second squared. Over the span of a single month, this seemingly tiny acceleration pushed Atlas off its expected path by about 80,000 kilometers. This acceleration is composed of two distinct components. One of them is pushing the object away from the Sun at a rate of 135 kilometers per day squared, which equates to about 60,000 kilometers per month, an enormous shift in such a short amount of time. And that's not all. Atlas is also moving laterally. It's shifting at a rate of 60 kilometers per day squared, which adds up to about 27,000 kilometers in lateral motion. This means that Atlas isn't simply drifting in a straight line. It's being pushed outward and laterally, simultaneously. Now, before anyone jumps to conclusions, let's clarify. This acceleration is not sending Atlas on a collision course with Earth. The deviation isn't enough to alter its trajectory toward any of the planets in our solar system, except for Jupiter, where it's predicted to arrive in March 2026. So, what exactly is non-gravitational acceleration? Think of it like this. When you throw a ball, gravity pulls it down in a predictable path. However, if that ball had small rockets attached to it, firing off in different directions, it would veer off course. That's the principle we're dealing with here. Atlas isn't merely following the path that the Sun's gravity would dictate. Something else is actively pushing it. For a comet, the common explanation for acceleration is outgassing. As the comet nears the Sun, the ice in its core heats up, turns into gas, and propels the object forward, much like a rocket engine. This behavior is completely normal for comets. But here's the kicker. The amount of gas that would need to be expelled by Atlas to generate this level of acceleration is extraordinary. And that's where things get interesting. Avi Lowe, an astronomer at Harvard, did the math using fundamental physics. By knowing the acceleration and the mass of the object, we can calculate how much gas would need to be ejected to produce the necessary push. Atlas weighs at least 33 billion tons, massive compared to the first two interstellar objects we encountered. It's between 1,000 and 1 million times more massive than Oumuamua or Borisov. The core of Atlas is estimated to be about 3.5 miles, nearly 6 kilometers in diameter. With such mass and acceleration, the calculations yield something remarkable. In order for natural outgassing to account for the acceleration, Atlas would need to lose about 1/16 of its total mass during the month it passed closest to the Sun. That's at least 5.5 billion tons of gas, and this amount of gas would form a colossal and intensely bright cloud surrounding the object. Such a cloud would be impossible to miss with our telescopes. Between late November 2025 and late January, multiple ground-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, will be closely observing Atlas. On December 19th, it will make its closest approach to Earth, at a distance of about 167 million miles. If this massive gas cloud is present, we will see it. But here's the question: what if it's not there? This is where the scientific debate takes an intriguing turn. If that massive cloud is absent, then the conventional explanation fails. Without the corresponding gas cloud to justify this acceleration, we must seriously consider the possibility that the acceleration is originating from something else, something technological. Here's the thing: we've witnessed a remarkably similar pattern with Oumuamua. This first interstellar object also exhibited non-gravitational acceleration, but curiously, there were no traces of gas or dust emanating from it. Even the highly sensitive Spitzer Space Telescope failed to detect any emissions. Scientists ended up labeling it as a dark comet, which, frankly, is an oxymoron. A comet's most distinguishing feature is its tail, made up of gas and dust. However, Atlas is presenting us with something far more perplexing than Oumuamua. It's displaying two additional strange behaviors that make it even harder to accept a natural explanation. First, let's talk about the brightness issue. As Atlas approached the Sun, its brightness intensified in a way that followed a power law with an exponent of 7.5. Now, for those who might not be familiar with the mathematics, here's what this means. Normal comets brighten as they near the Sun, but this increase usually follows a power law with an exponent between 2 and 3. In the case of Atlas, its brightness is increasing much faster, at a rate more than twice the expected norm. This behavior is unprecedented and goes against what we know about comet dynamics. And then there's the second bizarre characteristic, the ninth anomaly on the list. Atlas is blue. Yes, it's appearing bluer than the Sun itself at its closest approach. This is incredibly strange because dust typically makes objects appear redder, not bluer. In fact, Atlas's surface should be about 20 times colder than the surface of the Sun. Cold surfaces tend to glow red, not blue. So, what's causing this unusual blue glow? One possible explanation could be ionized gases, like carbon dioxide, emitting light directly. While this is scientifically plausible, it still doesn't quite fit the usual patterns we observe in celestial objects. Now, it's crucial to understand the real issue being debated here. Scientists aren't asserting that Atlas is unquestionably alien technology. The debate is rooted in scientific methodology. When data doesn't align with existing theories, the last thing you should do is dismiss it outright. The proper approach is to take the data seriously and explore every possible explanation, even those that may be uncomfortable. Some scientists, however, have argued that the data must be incorrect simply because they couldn't explain it. Dr. Avi Low responded to this by saying that dismissing data just because it doesn't fit your theories is terrible science. You can't reject data just because it challenges your current understanding. Atlas is a unique object in our solar system, one that doesn't just present strange facts, but also forces us to confront the implications of those facts and why they challenge our existing knowledge. Unlike anything we've encountered before, Atlas exhibits a series of anomalies. The first of these is its impossible trajectory. Atlas is traveling along a path that is just 5 degrees off from the plane where all the planets orbit around our star. Picture a table where all the balls are rolling on the same level. This level is called the ecliptic plane. An object coming from another stellar system should, in theory, come from any random direction in space, like a ball thrown from afar that could land from above, below, or from any side. But here's the catch. Atlas arrived almost perfectly aligned with the plane where all the planets in our solar system orbit. The probability of this happening by sheer chance is an astounding 0.2%, like trying to hit a tiny target in total darkness. Now, let's talk about the second anomaly, the jet that defies the laws of physics. During July and August of 2025, Atlas did something completely unprecedented in nature. It produced a jet of material shooting straight toward our star. All known comets do the exact opposite. They always form tails that point away from the sun, much like hair flowing backward when you run. This is a fundamental physical law. Solar radiation pressure pushes material outward, but Atlas completely broke this rule, as though someone were running and having their hair blown forward against the wind. The third anomaly is equally mind-boggling. Atlas is too big and too fast. This object is 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov, yet it moves faster than objects of similar size. It's like seeing a massive truck overtake race cars on a highway. Larger objects in interstellar space typically move slower due to the gravitational forces that expel them from their original star systems. But Atlas defies this principle with an incredibly low probability. The fourth anomaly involves the timing, which is simply too perfect. Atlas arrived at the perfect moment to pass close to Mars, Venus, and Jupiter, yet it remained completely invisible from Earth during the most crucial time, its perihelion. It's as though a tourist visited 3 major cities in a country, but somehow managed to avoid being captured by any of the main airport security cameras. The precise timing of this event is extraordinarily rare, rarer, in fact, than winning the lottery. Now, let's move to the fifth anomaly, Atlas's composition. Spectral analysis revealed that Atlas contains significantly more nickel than iron, a ratio that is typically seen in metallic alloys that are manufactured industrially here on Earth. Natural comets, on the other hand, are supposed to have a random mixture of metals, like a cosmic soup of elements, but Atlas has a specific formula, as if someone carefully selected the ingredients. The probability of this specific composition occurring naturally is incredibly low. Sixth anomaly, Atlas is drier than a desert. Comets are often referred to as dirty snowballs because they're typically made up of 80–90% water ice. However, Atlas contains only about 4% water, making it drier than many deserts on Earth. It's like finding an iceberg made almost entirely of rock. This characteristic challenges the very definition of what a comet should be, and it raises the possibility that Atlas may not even be a natural comet at all. The seventh anomaly is even more baffling. Atlas displayed a unique light polarization pattern that has never been observed in any known natural object. Polarization can be thought of as light's fingerprint. Each type of surface creates a distinct pattern. It's as though Atlas has a fingerprint that simply doesn't exist in nature, including any of the comets we've studied, even Borisov. The eighth anomaly is deeply intriguing. Atlas's arrival trajectory aligns with the direction of the famous 1977 WOW signal, the most mysterious radio signal ever detected, and widely considered one of the best pieces of evidence for extraterrestrial communication. The directional alignment between these two events is astonishing, with nearly 50 years separating them, yet pointing to the same cosmic address. The likelihood of this being a mere coincidence is incredibly low. The ninth and final anomaly is the most astonishing of all. Atlas now appears to be hotter than our very own star. Its blue hue suggests it has an internal energy source that is even hotter than the sun's 5×800 Grers Kelvin. Imagine finding a candle that outshines a bonfire. This extraordinary phenomenon suggests the presence of technology capable of generating temperatures far exceeding those of our sun, something completely beyond the scope of our current technological abilities. The laws of physics are unmistakably clear. For massive acceleration to occur, there must be a corresponding massive loss of mass. If we fail to observe the gas cloud that should be associated with this significant mass loss, we are left with only one possible explanation that fits the data. As we approach December 19th, when Atlas reaches its closest point to Earth, hundreds of telescopes will be scrutinizing the skies in search of the 5.5 billion tons of gas that should have been lost. If that gas isn't present, then we'll know that what we're looking at is not a comet at all. We will be witnessing something much more extraordinary, a piece of technology from another world, exhibiting propulsion capabilities that challenge the very foundation of our understanding of physics. The countdown to what could potentially be the most significant discovery in human history has already begun. In just a matter of weeks, we will know the truth, whether we are truly alone in the universe, or if we are witnessing the first confirmed arrival of a visitor from the stars.